Hello everyone, me, your friend Krishna Kumar Chaudhary came with the content. Our content is, today's content is Lagrange's mean value theorem. Lagrange's mean value theorem. Okay, our content is like, what is the statement of this? Suppose if any function, if a function fx is first, that is continuous in AB, closed interval AB, continuous in AB, differentiable in AB, then there exists at least one point C belongs to AB. Within the AB there will be the point C such that f dash C is equal to fb minus fa and by b minus a. This is your statement. Any function is continuous in a closed interval AB, differentiable in open interval AB, then within A and B, there will be the point. Suppose that point is C. Within the AB, within AB there will be a point C such that f dash C, the derivative at that point C, will be equal to functional value fb end point, functional value in fb minus fa, difference between functional value and divided by difference between the interval. What is the interval? Their gap. That will be your Lagrange's mean value theorem. Let us prove it. For proof, we will define a new functions. Let us define a new function. A function. Say that function named you as a capital Fx. Capital Fx. You have named it as a capital. How this capital Fx formation will be? The formation will be such types: numerator b minus a with Fx, and minus denominator into Fx, and the numerator fb minus fa, difference this numerator into x. This is your new function. You have defined the formation of the new function is this type. Now you will, to prove the Lagrange's mean value theorem, you will take the reference of Rolle's theorem, which you have earlier studied it. What is the Rolle's theorem said? The Rolle's theorem, it says that a function should be continuous, function should be differentiable, and functional value fa is equal to fb should be. Then there will be a point. Means fa and fb will be equal. Then within that a and b there will be a point C, say, such that it will be f dash c equal to 0 will be. This is your Rolle's theorem. So for applying the Rolle's theorem, first you need to show this is continuous, this new function is continuous, new function is differentiable, and fa is equal to fb you should show. This new function we will talk. This new function, which function? This new function means this new function capital Fx is continuous. Is continuous in same interval AB. Why? Why it happens so? Why this function is continuous new function? Since this fx is continuous, it's already fx and x is continuous. Why? Due to the polynomial function x is continuous. Continuous in AB. Now, due to this reason, the new function is continuous. Now, your target is to show, next step is to show a differentiable, whether the function is differentiable in that interval or not. So, f dash, for the differentiable, we will calculate the f dash x, means derivative we will calculate of the new functions. F dash x means what you will get, b minus a, this is the constant as it is, and differentiation of this is f dash x minus, and look, this constant will be as it is, fb minus fa, and then differentiation of this x in terms with respect to x, then you will get 1. Now what you will get then, f dash x is equal to b minus a, and then f dash x, no, minus, you can multiply with minus fb, and then plus fa. Now see this function is continuous or not. Yes, this function is continuous. This function fx we are taking, this function means capital Fx, new function, fx is continuous in AB. Why it is continuous? Since this you have given continuous, since this is in the question, since fx is continuous, we need not to see the constant, since fx is continuous in AB. Due to the reason this, you have found what, new function is continuous. Now your target to apply the Rolle's theorem, you have complete means it already satisfied the continuity, it already satisfied the differentiability. Now your target is to find fa is equal to fb. No, fa is equal to fb. Let's find it in the new function. If you will substitute, what you will get, fa your target is to find. Here you can say here fa, if you will complete, just substitute in term of a new function, instead of x you will substitute what, a. No, substitute there. After substituting, what you will get, you obviously b minus a as it is, here you don't have x, and fa minus, then here will be the fb minus fa as it is, and then instead of what, x, you can write a. So what you will get, fa, capital fa you are going to calculate, so multiply it, b times fa minus a times fa, and then multiply with a and minus at a time, then minus a times fb, and then plus a times fa. So obviously you will get cancel of this, so what you will get, fa, then you will get b fa minus a times fb. No, and similarly calculate the fb, capital fb. So calculation of fb, what you will get, just instead of where you have x in the new function, you should substitute the b, then what you will get, b minus a times of fb minus, and then fb minus fa, no, and then times b. Okay, and what you will get, fb is equal to b times fb minus a times fb, and minus b times fb, and plus b times fa. No, this you will get. So you will get cancellation of this. What you will get then, fb is equal to what, b times fa minus a times fb you got. No, this you got. Now we know that all three conditions for the new functions is satisfied. We can apply the Rolle's theorem. Then by Rolle's theorem, there exists at least one point C, no, within AB, belongs to AB, such that what is the Rolle's theorem statement, continuous should be, differentiable should be, and fa is equal to fb, then you will get f dash c is equal to 0. No, this is your Rolle's theorem. Okay, and f dash c means what you got, derivative. No, this is capital, obviously, because we are talking about capital fx. Now f dash c is equal to 0. So just substitute here in the derivative. Here you can substitute here. Okay, substitute here what, instead of x, what you will substitute, c substitute. Then after substitution, what you will get, then f dash c, if you will substitute, then b minus a, then f dash c minus fb plus fa, fb plus fa, and right side as it is 0. No, just you have substituted the values, or just take this functional value on the right, then b minus a f dash c is equal to fb and minus fa you will get. Then what you will get of f dash c values, that is fb minus fa and by b minus a. This is your Rolle's theorem, you have proved it. Okay, this is your required Rolle's theorem, you proved it. Now after the proving the Rolle's theorem, we will go the meaning. What is the meaning geometrically? What does it mean? So geometrical meaning of this Rolle's theorem, geometrical meaning. No meaning. What do you know about the Rolle's theorem? Okay, geometrically it shows that what slope of tangent to the curve says that curve is y is equal to fx at CFC, no, at the point C, no, is equal to the chord AB. What does it mean? That means in simple language you can say the major geometrical meaning of this Lagrange's mean value theorem is tangent at CFC, no, is parallel to the chord AB. This is the geometrical meaning. No, this is your major geometrical meaning of the Lagrange's mean value theorem. So let's see what does it mean. Suppose you have a curve, no, one of the curve you can say x, y. Suppose this is your curve, no, you can say this is your curve. Okay, this is your curve. Now this is y is equal to fx. Now we will talk, let us, here you have the interval a and you have interval, say suppose here b, no, and after this obviously the point you will get a of a here, no, and a point you will get here what, a b times b fb, no, b here and then fb. Then what does it mean? This means it will be the parallel to the chord. If suppose this is your chord of this function of this curve, then between a and b there will be point c, no, say that point is CFC on the curve, no, and if you draw the tangent, then this tangent will be parallel to the chord of the curve. Okay, chord of the curve. No, this tangent drawn at point C will be parallel to the chord. Okay, this is your geometrical meaning. After then I will talk about the corollary. Okay, some corollaries are there. For first corollary I will talk corollary 1. No, corollary 1 I will write here. I will talk about the corollary. Corollary first says that if any function, if f dash x is equal to 0, no, if it satisfies Lagrange's mean value theorem, okay, if it satisfies Lagrange's mean value theorem and if f dash x equal to 0 for all x in AB, then fx is constant in AB. Fx is constant in AB means function is constant type of function you will get. Okay, within this interval, okay, if derivative is 0, then function you will get constant type of functions. So to prove this, let us talk about the proof. To prove this, take within that interval any 2 points. Take any 2 points, okay, any 2 points. Say that point is x1 and x2 in AB. Okay, you have taken 2 points within A and B. No, such that obviously you will take one should be the less and another should be greater. With we will take with x1 is smaller than x2. No, these 2 points you have taken x1 and x2. No, now applying the Lagrange's mean value theorem, applying Lagrange's mean value theorem, in that interval we will talk in x1 and x2. X2 and x1 and x2, if you will take within that interval, if you will apply the Lagrange's mean value theorem, obviously we will get C. Any point we get C in that interval x1 comma x2, such that fc will be the what, fx2 minus f dash c. No, f dash c equal to fx2 minus fx1 and by x2 minus x1. Okay, this is your Lagrange. And what we have, obviously you have given f dash x equal to 0, then what you will get, 0 equal to fx2 minus fx1. Okay, and by x2 minus x1. Why it happens so? Since f dash x equal to 0 is given for all x in AB. No, this is the condition you have given. So instead of x you have taken as C point within this interval. If this could happen, then f dash c equal to will be this. No, now cross multiply, what you will get, fx2 minus fx1 equal to 0. So you will get fx2 equal to fx1. No, what does it mean? No, if everywhere the functional value is remains same, then that type of function is constant function. Hence function fx is constant. No, function is your constant function in which in the interval AB. Okay, why it happened? Why we can say the function is constant? Because the functional value remain as it is. If you will talk in figure, then you can say anywhere. If you will talk A and B, then you have here x1 and next you have x2. Then everywhere within that the functional value remain as it is. fx1 and fx2 remain same. Then we can say that type of function is your constant functions. Okay. Now next corollary you have corollary second. Okay. Corollary second says that if second of first, no, two are there, if f dash x is greater than 0, no, similarly earlier it was corollary first that f dash x equal to 0, then you got the constant function. If that f dash x is greater than 0, no, derivative is greater than 0 for all x belongs AB, no, then fx is increasing function. Okay, fx is increasing function. No, and we have similar pattern to prove it. Let's talk about the proof. Obviously you will take any 2 points, take any 2 points, take any that say x1 and x2, in AB. No, you will take 2 points in AB with we will take obviously the condition x1 is smaller than x2, and apply the Lagrange's theorem by using Lagrange's mean value theorem, mean value theorem in x1 x2 we get same as previous, we get C in that x1 x2, no, in x1 x2, such way you will get that f dash c will be your what, fx2 minus fx1 and by x2 minus x1, no, this you will get. Okay, after then obviously you have what, this one is greater, no, and since you can say, since what you have given, f dash x greater than 0 is given for all what, x belongs to, we can say AB, no, and what will be, and similarly we can say f dash c will be here greater than 0 for all x belongs to obviously x1 x2, no, this, and f dash c value is what, fx2 minus fx1 by x2 minus x1 will be a greater than 0, no, for all x belongs to x1 x2, no, and after the cross multiplication obviously you will get fx2 greater than fx1 on simplification. So what does it mean? You have found what, within this interval a and b, we have taken the x1 and x2, then if the functional value is increases here, no, functional value fx1 also increases, we have taken fx2, x1 is less than x2, then fx1 should be less than fx2. If you will get the condition that is function is increasing function, so hence function is increasing, hence fx is increasing function, increasing, no, increasing in that case. Similarly of corollary 2 you will have the next question you will get what, if just opposite, if f dash x is less than 0 for all, you complete yourself, for all x belongs to a comma b, then fx is decreasing function you should show. Okay, decreasing function, no, you should show it. How will you get? Obviously up to here will be same, just you will get what, whatever you have got here, just as it is you should write, just you will get fx1 greater than fx2 you will get. Okay, fx1 greater than fx2 or fx2 less than fx1 you will get, no, in that we can say the function is decreasing function. Let's talk about the some of the problem questions for this. Question, verify Lagrange's mean value theorem, for fx is equal to log x in the interval x belongs to 1 comma e. Now this is your question. You should show the verification for this function. Okay, verification for this function. So for verification obviously you will show the function is continuous, you will show the function is differentiable in that interval, you will show what, c, you will find c point that will lies within this interval, then it will be verified. So solution for this, what you will write, the function, this function, the given function is continuous. Oh, continuous. Why it become continuous? For all x greater than 0, any number that should be positive. Okay, any number that will be positive, then the function will be continuous. So we have the here 1 comma e value of e is 2.71 something is there. Now if we will substitute between the any values, you will get the values, so function is continuous. No, function will exist, so function is continuous in that interval. Okay, the given function is continuous for all x greater than 0. Now, so first condition satisfied. Now let's talk about the differentiability. So find the f dash x for this. F dash x, what you will get, 1 by x, no. And after getting this, the function is differentiable. Function is differentiable in 1 comma e. Why? Because any value you will substitute, obviously the value will exist. When it will not exist, obviously if you would get the value 0, no, like -1 comma or 0 to e would be there, obviously then it will be the not differentiable in that case, no. Now these two conditions satisfied. Now we have to check for a point, single point that will lies within that interval, no. So after this we can find, no, after this what you just, hence Lagrange's mean value theorem can be applied, no. The two conditions, hence Lagrange's mean value theorem can be applied, okay, because due to what? Due to continuity and differentiability, we can apply the Lagrange's mean value theorem. Now in the interval, in what interval? Obviously that interval is 1 comma e. Okay, so we have here, what is your Lagrange's mean value theorem? It states, the Lagrange's mean value theorem states that there exists C in A B such that f dash C is equal to f b point fb minus fa and by b minus a. Now for this interval, for ab interval, no, if the interval is 1 comma e, then what will, and f dash c is equal to, for the interval 1 comma e, you will get fe minus f1 and by e minus 1 for what? For 1 comma e. No, for this interval obviously you will get the formula, this one, okay. And f dash c means f dash x is 1 by x, f dash c will be your 1 by c. Just substitute it. 1 by c is equal to fe. So I am calculating here as a rough. Fe, fx is your 1 by log x. Then what will be your fe? Fe you will get log e. No, log e means 1. So obviously you will get 1 minus. And what will be your f1? F1 means log 1. Log 1 means 0. No, you will get here 0. No, roughly I have calculated. Just how did you get the values of this fe and f1? You see here in the rough, okay. And by e minus 1 as it is. So 1 by c is equal to 1 by e minus 1. Then c will be your e minus 1. Does this c lie? Obviously this c will belongs to 1 comma e. No, this c is belonging to 1 comma e. Hence Lagrange's theorem verified. Hence Lagrange's theorem verified, because all the conditions satisfied, no. Continuity is satisfied, differentiability is satisfied, it satisfies the point that will obviously lies within that interval. Now I would like to give a questions for you. If fx is equal to x square minus 4x is a function, no, function defined in 1 comma 3, find c prescribed by Lagrange's mean value theorem. Lagrange's mean value theorem. No, this c value you should find out, okay. For that what you will do, obviously you will show it the function is continuous. No, obviously this is polynomial function, then you will write the function is continuous Why? Since the function is polynomial function, due to the reason that the give function is continuous in that interval. And obviously f dash x, you will find out, no derivative, you will find, you will get 2x minus 4. The function is differentiable within that interval, no open interval, and take a point C, and just go on. Okay, and answer you will get of this C value, C you will get 2. Okay, you find out. Okay, thank you. This much for today.